Good afternoon and welcome to Purdue University and the CERIAS Computer Security Seminar. Our speaker today is Ashish Kamra. He's a student of Professor Elisa Bertino of Computer Science and Professor Guy Lebanon of Electrical and Computer Engineering. Ashish is a PhD student in Electrical and Computer Engineering. His research thesis area is in database intrusion detection and response. And his topic today is responding to anomalous database requests. Ashish?
Thank you, Randy, and welcome everybody to my presentation. My name is Ashish Kamra, and as Randy has described, and I'm going to present this work, joint work with Dr. Bertino, my advisor, and Rima Neme. Rima is again a PhD. Oh, it's right there. Rima is again a PhD candidate in the computer science department. Okay, so let's start. So the agenda of the talk is going to be, I'll define the problem that we are trying to address here, then some background on the problem and some motivation, and some kind of high-level overview of the approach that we are taking. I'll not go into all the details, and some little bit of experimental results, and then we'll discuss some of the future work related to this line of work, and then I'll be open to all your questions. So very simply in one slide, what I'm trying to build here is an integrated anomaly detection and response mechanism for relational databases. And we'll expound upon that as we go in the presentation. But the key word here is that we are trying to build an anomaly detection model, and integrated means that we want to have it inside the database system, not as a software not as a software system which is outside the database. It has to be inside the database server, and it's an anomaly detection model. So what is the motivation behind having this kind of thing? So there are essentially two questions that will provide you with the motivation. First is, why do you need an anomaly detection system? And second is, why do you need it tailored for relational databases? And I don't think I have a slide for why do we need a system, anomaly detection system which is specific for relational databases, but maybe that will come up on somewhere down the line in my presentation. Okay, so why do we need an anomaly detection system first? So there are a lot of data protection acts these days which regulate how the companies should maintain and store access to their data. So there are acts such as SOX, Sarbanes-Oxley, which is applicable to any companies which is publicly listed on the stock exchange. There is HIPAA, health related to patient medical data, and that's applicable to any organization that deals with patient data, and including Purdue, because Purdue has a push center. And GLBA is Graham-Leach-Bailey Act, which is applicable to any organization that stores financial data, and that includes Purdue also. So they have these acts have got many protections, regulations, whatever, but we are concerned about the provisions they have for data management. So this specifically asks you to record who is accessing the data at what time, when is the data accessed, where is the data accessed, and this is actually means you have to audit all kinds of data usage, and again prevent unauthorized access and modification to data. And very high level specifications are specified by these particular acts. So now the question you might have is, but don't we already have an auditing mechanism inside databases to address this? And of course there is. And don't we already have an access control system in place to prevent unauthorized access to data? Yes, we do, but we still have the problem insider threats. Insiders are malicious employees who have the necessary privileges to access data and manipulate data, and it's very hard to predict when trusted employees can go malicious and indulge in malicious activities. So we need an anomaly detection model, and the kind of model that we propose will become clearer in next few slides when we discuss the system architecture. Again, if the databases are accessed by applications, you have the problem of SQL injection. Now, SQL injection traditionally is an application level vulnerability. What happens very simply in a SQL injection is that you have an application that is interfacing with a database, and it accepts some user input, and it uses that user input to form SQL queries dynamically. Problem comes when like most software vulnerabilities, that the user input is not sanitized before you form the SQL query, which can allow a malicious user to form to submit a query to the database that is different from the original query intended by the application. So that is SQL injection. So a lot of solutions are there to address SQL injection at the application level, but we also believe that solutions must be devised at the database level also, where the data owners have no knowledge of what kind of application is accessing their data, and they are just providing a service as they are just providing data access as a service to applications. So they should have some solution at their end to detect a SQL injection attack. And we also propose some anomaly detection model to detect SQL injection attack. So these are real problems. It's not just I'm making insider threats and SQL injection up. Just to quote one particular survey, insider threats have been identified as the second biggest threat by organizations after hackers. And again, one of the findings of the survey was that majority of the incidents were detected only after the attack, that's in caps, and through manual procedures. So there really is a need to have automated systems for detecting insider threats attack to databases. And there are some real solutions as well. So you have a lot of third-party database access. Okay, actually should be database activity monitoring products. Anyway, so a lot of third-party commercial database activity monitoring products are there in the market. I just listed 3 of them. There must be more than at least a dozen that I can list. But these are, I guess, the most popular ones. And why I'm calling them as third parties, of course, you understand that they are outside the main database system. Interface between, they look at all database, all traffic going to the data center, and do auditing, do intrusion detection, anomaly detection, whatever they claim to do. But the goal of my work is to have an anomaly detection and, again, a response system built inside a database server, which is a problem that has not been addressed by the database vendors as yet. And the key reason is that because how is it going to affect the performance of the system, of the database system, which is very crucial. But we'll see. I don't have any experimental results for the performance yet, but towards the end of my work, probably I will. So now I'm going to go into some of the details of our approach. And this is a very high level overview of the system architecture. You have, let's look at the training phase at the bottom. So you have a profile creator module which can create profiles of users or applications that submit queries to the database, or it can also read queries from the audit log, assuming you have turned on auditing on the database system. And it comes up with some profiles. Now, precisely what these profiles are will depend upon the kind of threat model you have in mind for anomaly detection. Okay, so let's assume you have the profiles with you. Then that's the training phase. You learn the profiles over a period of time. And in the detection phase, for every new query submitted by the user, it goes through a feature selector which selects the features from the query. And again, the feature selection is dependent upon the kind of anomalies that you want to detect in the query. Now it goes through the detection engine, which is going to look at the profiles and apply some intelligent algorithms to come up with an assessment of the query. Now the assessment could be, okay, it doesn't think the query as anomalous, or if it thinks that the query is anomalous, it's going to submit an assessment to the response engine, and the response engine is going to look at some predefined